Welcome back. By this point, you should be familiar with how a typical successful coding interview should look like, especially how to solve a problem in front of an interviewer. And we're going to do a fun little exercise here. An interviewer just asked us a question. And this is the question right here. Given two arrays, create a function that lets a user know, true or false, whether these two arrays contain any common items. For example, if we had two arrays here, one containing A, B, C, X, and the other one Z, Y, and I, it would return false because there's nothing common between these two arrays. However, in this example, array 1 and array 2 both contain X. And because they have a common item, it should return true. So an interviewer just asked you this question. How will we go about solving it? Well, let's go step by step through our little guide. When the interviewer says the question, write down the key points at the top. Make sure you have all the details. Show how organized you are. Well, in this case, I've kind of done this for you over here. Ideally, you would write this out as you are coding and make sure that you show the interviewer, okay, if I had this example, it should return false. If I had this example, it should return true. Now, let's say the interviewer only gave you these points and no other information. At least now you have an idea of what our problem is going to look at and whether we want to return false or true. But we have two things that we want to do with our function. One is we have two parameters. And this function is going to return true or false. Now, in the second point, make sure you double check. What are the inputs? What are the outputs? Well, we've kind of already done that. And we've confirmed with our interviewer that we have two inputs, which are arrays. We can even ask the interviewer that, are they always going to be arrays? Is it possible that the input might not be arrays? Maybe an object, maybe a string. And we can confirm with the interviewer what those cases are. In our case, let's say that the interviewer says that these two parameters are always going to be arrays. And we always want to return true or false. And number 2 is really important here because we don't ever want to jump straight into coding. Even if you think you know the answer or you've seen this problem before, you know exactly what to do, don't jump straight into coding. First, explain your approach, like I'm doing here, talking it out. Because if there are any problems with your approach or with your understanding of the question, your interviewer is going to often point them out to you here before jumping straight in and looking at your code and saying that, no, this is wrong. This way, both you and the interviewer know exactly what the steps are that you need to follow. Now, let's look at point number 3 here. What is the most important value of the problem? Do you have time, space, and memory to run this function? What is the main goal? Now, because this is a simple question, we might want to ask the interviewer how large this array is going to get. Because if the interviewer says the array is never going to be more than 5 items, well, then maybe we don't have to worry about big O or time complexity or space complexity as much. And then you can ask the interviewer, is our goal here to be as efficient as possible with our function? What's more important to us? Is time complexity more important or is space complexity more important? Maybe the interviewer might tell you that we just want the most efficient function that you can come up with, assuming that the array can get very, very large. So let's say in here we have two parameters, arrays that have no size limit. So these arrays can get really, really big. And in terms of returning true or false, that's all we want. We just want a Boolean return. Now, number 4, don't be annoying when asking too many questions. And we're kind of getting to that territory where we've asked a lot of questions to the interviewer and we kind of have an idea of what we want to do. We can keep asking them questions, but remember, you usually have a time limit. You don't want to keep bothering them, annoying them, and just asking them all these small little questions before we start coding. Keep time in mind. And I think at this point, we have an information that we can move on with our assumption to start solving the problem. So, number 5, start with the naive brute force approach. First thing that comes into mind, it shows that you're able to think well and critically. And you don't even need to write this code, just speak about it. This is always a case when an interviewer asks you a question. They usually have an easy solution that we call the brute force, which is not the most efficient, but usually is the easiest one or the first one that comes up in mind. So in our case, if we look at this, during an interview with a time limit, you might say, this looks like a nested loop where we're comparing A with Z, and then A with Y, then A with I, and then we go to B with Z, B with Y, B with I, and then so on and so forth. So immediately this looks like we're comparing two different arrays, and we're going to have two for loops, one nested on top of each other. And right away we know that that's a big O, which we've talked about, of O n squared. Most likely during an interview, nested for loops is something that we want to avoid. Just telling the interviewer this solution, even though it's not the best solution, already shows that you're thinking clearly about the problem. And it also gives you a point from where to improve from. Now, you don't necessarily have to code this part, and it's usually enough just to describe how it works, kind of like I just did now. But depending on your time, you may or may not want to code this as well. The important thing is that you let the interviewer know that this is the brute force or the easy, naive solution that may not be the most efficient. At least this way you have the right answer than running out of time and not even having an answer. Number 6 here is tell them why this approach is not the best. So in our case, we said that the code might be not efficient, or we might have not readable, or a code that is going to be really complicated and hard to read for other developers. With my demonstration, because I just want you to think about this and so I can be more clear of why this is O(n) squared, I'm going to just code, and most likely you wouldn't do this in an interview. I'm just going to code the brute force solution so you can see what I mean. I'm going to have a function, and this function is going to say contains common item, and it's going to receive two arrays, array 1 and array 2. Now, we are going to take the first array and do a for loop. So I'm going to say for let I equals 0. And we'll say that as long as I is less than the array 1.length, so that's the length of the first array, we're going to increment I. And within this loop, we're going to have another for loop. So in the first time around, we're going to grab A from the first array, and we're going to compare it to the second array, Z, Y, and X. So we're going to have a for loop here, and we'll say that we'll have the same thing. This time, instead of I, we'll say J equals 0. And this J, as long as it's smaller than array 2.length, it's going to increment every time we loop through it. And finally, within here, we're going to do a bit of a comparison. We're going to compare A to Z, then A to Y, then A to X. So if I go over here and say if array 1, index of I, so array 1 at index of I, so the first time around I is going to be 0. So that means array 1 is going to contain A. Let's actually grab this so we can see it better. At the top over here, I'm going to have two arrays here. And we're going to say that array at 0, first time around, is going to grab A. And if that equals array 2 at whatever j is. J is the index of array 2. So first time around, it's going to compare it to z, so a and z. And then as this increments, it's going to compare it to a and y. And then this is going to increment, compare a to x. And then we go to the top loop again. I gets incremented, so it becomes 1 now. So we're going to start comparing b to z, b to y, b to x, and then c to z, c to y, c to x, and so on. If that's the case, and if this is true, we just want to return true. Otherwise, if we loop through this and this never matches, well, in that case, we can just return false here. Now, let's see if this works. I'm going to just say contains common item, and we're going to give it the two arrays, array 1 and array 2. If we run this, and let's make this a little bit smaller so you can see, if I run this, I get true because there's a common item of x. If I change this to now have r and I click run, I get false. Again, if we change this to a and click run, we get true because a and a match up. Looking at this, and we look at number 6 over here, that is, let's make this screen a little bit more organized so we can read this. Number 6 is tell them why this approach is not the best. Now, again, you might not have time to even code this, but we can right away see that we have 2 for loops, one nested after another. And because we've already talked about this in the big O section, we know that we have a big O when it comes to time complexity here of, well, we have an array A and another array. So that means multiply by B. Again, this is a bit of a trick because these two arrays can be different sizes. We can't just say O(n) squared because these two arrays can have, again, like I said, different sizes. So this is a bit of a trick, and it's a good thing that we wrote it out because now we see that instead of O(n) squared, this is more like OA times B. If the array sizes are the same, they'll be the same as O(n) squared, so that's pretty slow. So number 7, walk through your approach, common things, and see where you may be able to break things. Any repetition, bottlenecks like O(n) squared, or unnecessary work? Did you use all the information the interviewer gave you? And so on and so forth. Now, looking at this, I can say that we could probably do better. You might not see a solution right away, and that is because you need to practice a few of these problems to understand a common pattern. But one of the most common patterns when it comes to nested for loops is that you might be able to use something called hash tables, which we'll get to. In JavaScript, they're called objects, in order to speed things up. Is there a way to turn this OA times B time complexity into something faster? We are doing a bit of unnecessary work where we just keep looping AZ, AY, AA, and then we go BZ, BY, BA, and we're doing this comparison in the same work over and over. What if we have a better solution? I'm going to comment this out for now and scroll all the way to the bottom, and we don't need this anymore, and try a different solution. I'm going to bring the array down here just so we can see it. Now, before we start actually coding, let's think about what steps we want to take. Well, what if we had a function that takes the first array, so let's say array 1 is going to be converted to an object. And this object is going to contain something like this. It'll contain, and let's make sure we comment this out. It's going to contain A equals true, then B equals to true, C equals to true. And then finally, it's going to have x equals to true. Now, if we create an object like this, we can now use this object with our array2 to just say, array2, can we check each item in array2 to this object and see if a property exists? Ideally, we can do something like array2 index and see if this equals any of the object dot properties. Okay, let's walk through this one more time. This is a common pattern that you're going to see a lot when it comes to improving time complexity. So if you don't get this right away, don't stress out. This is something that will become more and more familiar to you as we do more problems. But if I'm able to convert the first array into an object that looks like this, now instead of having to loop over both arrays, I can just loop through the second array and just simply check if the property z exists on this object that we created. No, it doesn't. Does the property y exist on this array? No, it doesn't. Does the property a exist on this object? Yes, it does. That means we have a common item. Now, to show you how this actually works and why this solution would be better than the first one, I need to actually start coding it. But as we go through number 8, we see that before you start coding, we want to walk through your code and write down the steps you're going to do. So let's start doing that. I'm going to say that we're going to create a new function, contains common item. And this one I'm going to add 2 because this is our second function. It's going to take in an array of 1 and array 2. And now this function, let's make this a little bit smaller so it looks nicer. There you go. This function is going to say, first, I want you to loop through first array and create object where properties equal items in the array. And then the second thing will be to loop through second array and check if item in second array exists on created object. Now, before we even start coding this, I can right away sense that we're going to have a better performance than the first array that was O, A times B. Because what we're going to do is have 2 loops, but these 2 loops aren't going to be nested. Remember, in the first solution, we had nested for loops. In this solution, in our second solution, we're going to have 2 separate for loops. And if you remember our big O analysis, when we have steps one after another instead of nested, the big O becomes A plus B. We have a potential solution here, have a time complexity of A plus B instead of A times B. Those are big savings. We need to start actually writing this code to see if we can solve this problem. And because this video is getting long, we're going to do this in the next video. But I want to show you right here what we've just done. And that is, although we haven't given a clear solution, we've been talking about how we solve the problem. The interviewer sees how we think, sees what steps we take, and sees that we're making smart, critical decisions to go from understanding the problem to solving the problem in a naive way, understanding why this might not be the best way, and then start to think about possible solutions. And the beauty of this approach is that no matter whether we get this part correct, maybe our assumptions are wrong and we can't do this, we're showing the interviewer that we're thinking through a problem and we're making small logical steps towards a solution. And this is a lot better than just coding right away, trying a solution, and see if you get it right or wrong. An interviewer is going to have a good understanding of your abilities and your thought process this way. And these are the type of people that they want to hire. So in the next video, let's finish out this problem, let's code it, and see if we can make this solution more efficient by converting it to OA plus B. I'll see you in the next one. Bye-bye.